Module 5 Web3.js and app development. This lesson guides you through the essential steps to set up Web3.js, which is a popular JavaScript library for interacting with the Ethereum blockchain. We'll learn how to configure our development environment and learn how to get started in building our decentralized applications, apps using the powerful Web3.js framework. What is Web3.js? We have already talked about this in great detail, but just to give a quick recap, Web3.js is again a powerful JavaScript library that simplifies the process of interacting with the Ethereum blockchain. It enables developers to perform a wide range of tasks, from deploying and interacting with smart contracts to even managing Ethereum accounts and transactions. By abstracting the complexities of the Ethereum network, Web3.js provides a user friendly interface for building apps that can seamlessly integrate with the Ethereum ecosystem. Web3.js acts as a bridge between the JavaScript web-based application and the Ethereum blockchain. This in turn allows developers to write code that can securely communicate with the distributed network. Security is important to us, right? This library handles the low-level details of Ethereum node interaction, network requests, and data formatting, which in turn frees developers, which is us, to focus on the core functionality of their app, right? You don't have to care about low-level details. You can just focus on the core functionality. For example, in your programming language, if you have to find a number to the power 5, right? Then you'll write a into a into a into a into a 5 times, right? But for example, if you just had a function called to the power 5, then you just have to write 8 to the power 5 and you can get it automatically, right? So again, you're leaving the low level details and you're focusing more on the core functionality. So prerequisites, Node.js and NPM. You have to ensure that you have Node.js and its package manager, NPM, which is Node Package Manager, installed in your system. These tools are essential for running JavaScript code and managing project dependencies, which are required for setting up and using the Web3.js library. So you obviously require a bit of JavaScript knowledge, right? A basic understanding, very basic understanding of JavaScript programming is necessary to work with Web3.js effectively. You'll need to be familiar with concepts like variables, functions, objects, and asynchronous programming to write code that interacts with the Ethereum blockchain. This is something you could have done in other languages too, so you should just know how to do it in Java a little. And Ethereum account, while this is not strictly required, having an Ethereum account and a local Ethereum node setup can be helpful for testing and debugging your decentralized applications. This will allow you to interact with the Ethereum network directly from your development environment. So next, let's talk about the steps, right? So the very first step is installing Node.js. First crucial step is to install Node.js, which is a JavaScript runtime that allows you to run a JavaScript code outside of a web browser. This comes bundled with NPM, the Node.js package manager, which you'll use to install and manage the web3.js library. Right? So I have just put it in a flowchart for you to understand. To download, you can use the official nodejs.org website and download the latest version of node.js for your operating system. Next, you have to install, right? They have instructions. You must have installed some, you know how to install this, right? And finally, you have to verify the installation. Open a terminal or command prompt and run the commands node version and npm version. This is to ensure that the node.js and npm have been installed correctly. With Node.js and NPM setup, you are now ready to start working with Web3.js and build apps that can interact with the Ethereum blockchain. Okay, so next we are going to focus on creating a project directory. In very basic programming, you know how to do project directories, right? So again, this is what you need to do for Web3.js also. So first you open your terminal. You begin by opening your computer's terminal or command prompt. This is where you'll run the necessary commands to set up your Web3.js development environment. Then you create a new directory, right? So this will help keep your project files organized and separate from other work on your system. You know how to use the mkdir function in your command prompt, right? So mkdir web3/setup. This is just an example. And then you navigate to the current directory. Change your current working directory to the newly created one. This will ensure that all subsequent commands are executed within the context of your web3.js project and nowhere else. cd web3 setup. Next, you have to initialize a node.js project, creating a package.json file. To kick off your web3.js project, run the command npm init y in your project directory. Command automatically generates a package.json file which serves as the manifest for your Node.js project containing metadata and dependencies. JSON stands for JavaScript Object Notation, right? Okay, so your next step will be to manage project dependencies. The package JSON file keeps track of all the external packages and libraries your project relies on, making it easy to install, update, and share your project with others. It's the central hub for managing your Node.js project's dependencies. Then you have to ensure consistent setup. By initializing your project with npm init-y, you ensure a consistent starting point for your web3.js development. This allows you to focus on building your decentralized application without worrying about setting up the project structure from scratch. Next is installing web3.js. You've already installed node.js. Now you have to install web3.js. So you open your terminal, you navigate to your project, right? You change your current working directory to the root of your web3.js project. And then you finally install web3.js. Run the command npm install web3 to add the web3.js library to your project. The npm install web3 command downloads the latest version of the web3.js library and adds it as a dependency in your project's package.json file. This makes the web3.js API available for use throughout your decentralized application app development process. Next, what you have to do is set up a local Ethereum node, right? So you first begin with downloading Ganache, right? To set up a local Ethereum node, we usually use Ganache, a personal blockchain for Ethereum development. Visit the Ganache website at, this is the link given, trufflesuite.com, Ganache, and download the latest version for your operating system. Next, you just have to install Ganache. There will be installation instructions provided on the website. The process is quite straightforward. It should take only a few minutes. Once installed, you will have a local Ethereum network running on your machine. Next, you have to run Ganache. After installing Ganache, launch the application. You'll see a user-friendly interface that provides you with a local Ethereum blockchain, complete with pre-funded test accounts, and the ability to customize the network settings to suit your development needs. So next, you have to learn how to connect an Ethereum node. Right? So first, you have to require web3.js. So you import the web3.js library into your JavaScript project. Right? The code is also given below, right, under the steps. Const web3 require web3. Okay, and next what we are doing is we are creating a new web3 instance. We're initializing a new web3 instance and passing the URL of your local Ethereum node. And finally, we connect to the node. The web3 instance will establish a secure connection to the Ethereum node, allowing us to interact with the blockchain. The code is also given, right? So the provided code snippet demonstrates how to connect to a local Ethereum node running on Ganache using the web3.js library. By initiating a new Web3 object and passing in the URL of the local node, we can now leverage the full suite of Web3.js APIs to build our app and interact with the Ethereum blockchain. Our goal essentially, right? Next, what we have to do is verify the connection. We have made a connection. You should verify that the connection is actually working, right? So we check the block number. We verify the connection by retrieving the block number. Right? Then we call Web3 API. We use web3.ethereum.getBlockNumber method to fetch the latest block. And then we log the result, display the retrieved block number in the console to confirm connectivity. Web3.ethereum.getBlockNumber dot then console.log. Once you have connected your web3.js application to the local Ethereum node, we can easily verify the connection by calling the web3.ethereum.getBlock method. This API retrieves the current block number, which we can then log to the console to confirm that our application is successfully communicating with the Ethereum blockchain. Simple check ensures that our development environment is set up correctly and is ready for further interaction with the decentralized network. The next step is creating an Ethereum account, generating a new account, right? So the code is given, right? I'll explain the steps and the code will explain everything. The provided code snippet demonstrates how to create a new Ethereum account using the Web3.js library. This is the starting point for any user, right? So you always start, right? When you have a race, when you're running a marathon, you have a starting point. First point is always creating an account. Next is accessing the account details. So we use the web3.ethereum.accounts.create method. This generates a new Ethereum account with the resulting object containing the account's address, private key, and other sensitive information that can be used for various blockchain operations. Next is storing account securely. It is crucial to handle the generated account information with care, as the private key is the sole means of accessing and controlling the associated Ethereum account. Proper storage and management of this private data is essential for the security of our decentralized application. I have explained everything, right? We have used the web3.ethereum.accounts.create method and we are just logging it into the console. Next, what we have to do, we have to fund the account on Ganache, right? So we open Ganache, launch the application in your machine, we locate the account, identify the Ethereum account you created earlier in the last step, right? And then we send test ether. So Ganache has intuitive interface and we can use this to send a test amount of ether to our account. So Ganache, the personal Ethereum blockchain for development, provides a simple way to fund your newly created Ethereum account with test ether. This is like simulative ether. It's not real ether, it's test ether. The purpose of this is simulation, right? This allows you to simulate transactions and interact with the blockchain without using real cryptocurrency, which costs a lot of money, right? Like one ether is like thousands of dollars. Why would you spend that to just test your account? So you have test ether for that. By leveraging Ganache's user-friendly interface, you can quickly send Ether to your account, enabling you to test your decentralized application's functionality and logic without the need for real-world financial risk. So sending Ether, right? This is the step, right? So we first prepare the transaction. To send Ether from one account to another, you'll need to construct a transaction object with the necessary details, including the sender's address, the recipient's address, and the amount of Ether to be transferred. So we use the web3.js API. So this will provide a simple and intuitive way to execute these type of Ether transfer transactions. The web3.ethereum.send transaction method allows you to easily send Ether between accounts. So next we have to specify transaction details. In the provided example, the from field represents the sender's address and the to represents the recipient's address. The value field specifies the amount of Ether to be transferred. Using the web3.utils.y function to convert the amount to the appropriate unit, right? So like if something is given in kilometers and we need it in meters, we'll convert it, right? So that's what we use the web3.utils.2y function. We are converting it from ether to y, right? This is the code given again as I specified from sender address to receiver address, value what value, and we have used the web3.utils.2y function. So smart contract interaction. So first what we have to do is we have to connect to the contract. To interact with a deployed smart contract, you first need to create a web3.js contract instance. This is done by providing the contract's application binary interface and address. So the ABI defines the contract's application programming interface, including the available function, their parameters, and return types. This is basically just gives you the structure of the application, right? Of the programming interface. This is basically used for structural purposes. It represents the structure. This information is crucial for interacting with the contract programmatically. So next what we have to do is specify contract address. The contract address is the unique identifier on the Ethereum blockchain where the contract's bytecode is deployed. This address is used to direct your transactions to the correct smart contract instance. So const contract, new web3.ethereum contract, you specify the ABI, application binary interface, and the contract address. So calling contract methods. So we invoke methods, right? So we call contract methods to interact with the deployed smart contract. We use .call. We leverage the contract.methods.method name.call syntax to execute read-only contract methods. Then you handle results, right? Process the return results from the contract method call in the promises, then handler. So the provided code snippet will demonstrate how to call a read-only method on a deployed Ethereum smart contract using the web3.js library. By chaining the contract.methods.method name and .call functions, our application can invoke the specified contract method and also capture the return data. The resulting promise allows us to handle the method's output, typically by logging the result to the console for further processing or display in our decentralized application's user interface. Contract.methods.methodname.call and then result equal to console.log result. Okay. Next, we'll talk about sending transactions to contract. So our first step is to modify the contract state, right? So we send a transaction to invoke a contract method that alters the smart contract state. Then we leverage send, right? We use send contract.methods.method name params.send syntax to execute the transaction. After that, we specify sender address. In send options, include the from field to specify the Ethereum account address that will be sending the transaction. The provided example will demonstrate how to send a transaction to a smart contract using web3.js. By chaining the contract.methods.method name params and .send functions, we can invoke a contract method that modifies the contract state on the Ethereum blockchain. The from option in the send call specifies the Ethereum address of the account that will be executing the transaction, allowing us to interact with the contract on behalf of a particular user or entity. Contract.methods.method name params.send from and your address. Okay, next we'll talk about handling events, right? So listen for contract events. Your Web3.js application can listen for specific events emitted by deployed smart contracts. This allows our dApp to reactively respond to changes and actions on the Ethereum blockchain. After that, we use contract.events API. So I'll explain this with the code snippet, right? So the provided code snippet, which is given in front of you below, demonstrates how to use the contract.events.event name method to subscribe to a contract event. The from block option specifies the starting block number to search for the event. Contract.events.event name from block 0 error event console log event. After this, we process event data. When the specified event data is detected, the callback function is invoked, passing the event object. You can then parse the event data and integrate it into your dApp's functionality and user experience. Okay, so the next step that we have to make sure we do is integrating with front end. So first we obviously have to include web3.js, right? So to integrate it, you need to include web3.js by adding a script tag in our HTML file. This script tag redefines the CDN hosted minified version of the library, making it readily accessible for front-end development. CDN stands for Content Delivery Network, and it's a system of distributed servers that deliver web content and other internet-based services to users based on their geographic location. They're basically designed to improve the speed, reliability, and efficiency of content delivering by caching and serving content from servers that are closer to the user's function, right? So we next leverage CDN by referencing web3.js library from a content delivery network. You can ensure that your users have fast and reliable access to the necessary JavaScript code, improving the overall performance and user experience of your app. After that, we connect to the blockchain. With Web3.js included in our front end, we can now interact with the Ethereum blockchain directly from our web application. Allows us to build a rich user interface that seamlessly integrates with the decentralized components of our dApp. So the code here is script src https cdn jd deliver .NET npm web3 test web3.min.js script, right? In this case, this is the URL to the web3.js library hosted on the JSDeliver CDN. When a user loads your web page, the browser fetches this library from the nearest JSDeliver server, ensuring fast and reliable delivery. Okay, so next is connecting with MetaMask. So we already know what MetaMask is, right? It's a popular browser extension that allows users to securely manage their Ethereum accounts and connect to dApps. Right. So the steps to do this is first we enable MetaMask. So we allow Web3.js to access MetaMask's Ethereum provider. Then we initialize Web3. We create a new Web3 instance using the MetaMask provider. That we interact with blockchain, we leverage the connected to communicate with the Ethereum network. By integrating MetaMask with your Web3 powered dApp, right, you can provide a seamless user experience where your users can easily interact with your application's blockchain-based functionality. Provided code snippet demonstrates how to enable the MetaMask provider and initialize a new Web3 instance. enabling your front end to directly communicate with the Ethereum network. Const Web3 equal to new Web3 window.ethereum await window.ethereum.enable. So finally concluding everything. So let's take a recap of setting up web3.js. This presentation that we did today has guided you through the essential steps of setting up web3.js, which is the leading JavaScript library for interacting with the Ethereum blockchain. From installing Node.js and initializing a project to connecting to a local Ethereum node and creating Ethereum accounts, we have learned the foundational knowledge required to start building dApps. And let's talk about the importance of Web3.js in dApp development. Web3.js is a crucial tool for developers looking to create dApps on the Ethereum network, providing a seamless interface to interact with the blockchain. Web3.js simplifies the development process and enables us to leverage the power of smart contracts and Ethereum's distributed ledger technology within our applications. So that's it for today, guys. Thank you very much, and I'll see you in the next video.